everybody. The key thing for us is to think about this whole journey we're on now. Is we think there's one key part of the industry, the gaming industry, that is inspiring us. You've got kids that have got Xboxes and PlayStations. They're having amazing experiences in their bedroom looking at all these games and everything. This guy, a couple of years ago, he inspired me to start looking at this, and it was driven by him. And we actually think if you start to look at what's happening in that industry, it can change the IT industry. So what we're going to do today is we've got a fictitious company called... Second part of the demo is Gary here is going to show us the future. He's going to show us the future, what's actually possible. So I think you go and set up and get your thing, and I'll start the proceedings. Okay, so hopefully some of you recognize this. So the film The Matrix, right? This represents the code that's running the world that we're in today. Because we're not actually here, we're in these pods somewhere else, powering an alien civilization. So if you've seen the film, that's what that means. So that code is explaining all those type of things. Now in the film, we've got Keanu Reeves, Neo. Now he's a very experienced guy. He's in the virtual world, but he starts to be able to see the way the actual virtual world has been rendered and all the code. He is the one. Now us mere mortals, we're stood over here. We're in the real world, right? We think this is the real, but in fact it's not. Now the point of this analogy is, I'm sure some people in this room have been in that situation where you're faced with a bank of monitors on a wall full of graphs and charts and data and information, and somebody comes up to you, Neo in this case, and says, look at all this information, isn't it amazing, right? And this tells me exactly what's happening in your business. It tells me how the marketing campaign's going. It's telling me how your IT system's working. It's telling me everything about you. And you look, and if you're honest with yourself, it sounds good and you understand the explanation, but it's still quite confusing. It still looks a bit like that as far as you're concerned. So what we think is, excuse me, the thing. So what we think is that as part of this new world, we want to learn how to actually do some more visualization and interaction and make it better for our people. Now, if we take an example, I worked with Gary on a number of projects over the years, and we worked with a big client, HMRC, and we built them a big system full of about 80 apps, 2 data centers, hundreds of servers. It was completely crazy. It was massive. Now, what used to frustrate the hell out of me was that when we had this bank of monitors, which is really important, because I'm an expert, I can see what's happening, I can understand what's happening. But when I talked to the client, when I talked to the person who tried to explain what was actually going through, what this all meant, it was very difficult for me to do. I had to revert to whiteboards, PowerPoints, and analogies, really, and that's how I would describe it. Now, if you wind the clock forward now, and you look at I don't know what you guys are doing, but I know what we're doing. We're building sophisticated platforms across Amazon, Azure, and Google, putting them in China. The whole problem got a lot worse. There's more components, everything's code, there's more things. If you add microservices on top of it, I'll give you an example. Those 80 apps we built would become tens of thousands of microservices apps because there was so much in each of those apps. So you think about the problem now. It's more dynamic than ever before. There's more components you've ever got, and you've got to somehow make a picture of them in your head and how it works. So the 4 key technology we think, and this is like, you've heard of the term probably recombination or smart recombination. That's where most innovation comes from. It's not by new ideas, it's by taking other ideas. The first thing that's the really important thing here is API cloud services. So Amazon pioneered this, I don't have to say much. What this allows me to do now is our teams, they can programmatically build out data centers and applications and services automatically within minutes. The second bit of critical technology is automation software. Now, we personally use a product called HashiCorp, which is an open source product that allows you to provision out vast numbers of servers and load balancers, and then using the other techniques like Go, for example, and Rundeck, we can then deploy our apps onto those in the cloud. That has been around about, say, 10 years, really doing it. This guy here in the last 5 years has exploded and become extremely mainstream. So those 2 things give us the ability now to build things really quickly, right? this is the cool stuff, right? Now, Apple have just announced AR support for the iPhone 8. We've got Microsoft HoloLenses in dev, which means you can buy a development kit for it. That's going to basically put some glasses on and it will beam in front of you, augment your world with that. And then we've got Oculus Rift, which Gary's going to show us in a minute, which is £400, right? And you can get yourself some VR kit. This is mainstream, main market, and it's cheap and it's low cost. And it's actually, if you think about it, it's all because of the phone. The phone is the thing that is basis of all of this, which is a very advanced piece of technology now. The secret sauce is the gaming engine. So if you've got kids, they'll be on the PlayStation, the Xbox. We can provision it onto the cloud services and we can get real-time data from those cloud services so we can really, really understand what's happening. Then we have to think about how we're going to render that into a three-dimensional image. We can use our gaming engine to do that, and how we can access that information. We can actually be a tablet or some of these virtual reality and AR kits. And that's the combination of those technologies we think is going to revolutionize our industry in terms of the way we visualize and interact. What I want to quickly do is a quick demo. So if you look over here. So what I've got up here is a classic example of I mean, do you all understand what that is? This is Java heap sizes. It's a whole bunch of stuff to do with the platform. Does it mean that much to everybody? What I've got here on the left-hand side is, so Clyde Electronics, right? And what I'll do is, we've got a browser app here on Chrome, which is going to effectively, and what I'm going to do is I'm just going to, this is an API request I made before. So what we've got happening here is, on the cloud, we've got 4 microservices running, and we've got an app here on my machine, and that's going to access that microservice app running on an iPad, and it's going to then go to Twitter and Yammer and scan for a string. So in here, I'm going to put cwin 17. Oh, wrong. Was that in the... It's amazing you can't do anything simply when you're up here. Yeah. So I'm just going to make a search there, right? And what's happening behind the scenes when it does that search, and by the way, I'm at the mercy of the internet here. So that's just come back, and what that's done is it's gone off to the cloud, and in here, if I look down here, you see Simon Hopkinson is one of our guys. He just wrote 9 AM updated hackathon and so on. And there you go, that's the API request just come in. And I can see that one request caused 25 requests to happen on my microservice platform. So when I pushed it in, something happened and 25 requests were made, right? If I can't see this screen, so small, right? If I look, this tells me the amount of capacity that's being used on my platform. And if I'm just, for example, going to very quickly find my mouse, if I do multiple searches, like I'm putting some load in the system, what we should see here is that the CPU will start to be used because I've made multiple requests. There you go, CPU's come in, it's hit the thing, and then what we're going to do is we'll see on the dashboard those things. The last thing I want to show you is, very simply, we've got a Yammer proxy, a Twitter proxy, there's a filter service somewhere in here, and that's the aggregator service. 4 microservices, one that does a search, and then it searches the different sites. What we've also got here is a bunch of, we're running a Carbon hackathon at the moment, and we've got about 50 teams accessing Capgemini's Carbon data, and they're innovating around it, so that's what those other microservices are. So they're the microservices, that's the thing, and if I just finish off here, and you can see the other API requests come in. Now, the point of me showing all of that is that despite what we've just shown you there, how many of you actually got a good picture of what I've actually described in the cloud? Is there anybody bold enough to think they've got a really good picture of it, right? Because I've shown you a bunch of data. Now, if you take that into an operational data center, that's exactly what it's like, unless you have somebody. So what I would, at this traditional point, what you guys do, is I would scan through my PowerPoint, but then what I'd do is I'd bring up a diagram like this, and I'd say, what you actually saw, guys, was we had Google up here. It made a call to my social search engine service here. That was the step 1. Step 2 was to search Yammer and Twitter for that search string, cwin17. And then what it did was it came back and it went to a profanity filter and looked for any swear words so that it didn't put any tweets back with any swear words in it, right? Now, the whole point of that is, and I have no idea what time it is, I hope I've done okay. The whole point of that is that, and Gary, you might want to come up at this point, is I had to still use that diagram to describe what was happening out there on the internet, right? And that's just unsatisfactory. That's what we think, right? Just unsatisfactory. And Gary is now going to show us, when he's started up his machine, a way of taking that world and all that data and making it into something that you guys might find quite engaging. And I want to be very clear in one thing here. This is not being aimed at, yes, please. This is not being aimed at ops guys, engineers. It can be used for that, and it will be useful for that. The kind of information that we're going to have, you're going to see now, is all about how much is my business costing me? How much business am I making? How's my marketing campaign going? It's about modeling your whole business, not just about your IT that runs your business. But IT that runs your business is a good starting point, right? Because we've already got that problem, and we've already got some really good use cases of how it happens.
Sorry, Ben, I just...
That's fine. So, how long do you need?
No, I'm done. I'm done now.
So I'll hand over to Gary Baptist.
Okay. Hi, everyone. So why do we believe that the gaming industry can have such an impact on our industry? Well, to answer that question, let's just take a moment to think about computer games. But let's not think about computer games as computer games. Let's think about them as software, because that's all they really are. If you spend any time analysing computer games, it doesn't take you long to realise that they're very sophisticated simulations. They run in real time, and they generate, they process, and they store, and more often than not, they distribute across a network vast amounts of data. And they run quite complex algorithms on that data. So we have rendering algorithms to draw to the screen. We have physics algorithms in which to accurately simulate movement. We have artificial intelligence, so we can create worthy adversaries. And all of that is centered around a domain model that could be anything. That could be a sophisticated World War II simulation, or it could be running a theme park. It could be anything. And yet the games industry has the skill to create a user interface and a user experience that is not only functional and accessible by a huge user base, it has the capacity to make that software into something that is fun. That is world-class software. If you can take software and make it fun, that is world-class. I could not think of a better compliment as an engineer if users said to me about some software that I had written that they found it to be fun. I couldn't imagine anything better. Just as we build platforms to help developers deploy integrations and microservices, the games industry build them too, and they call them platforms too, and they call them gaming engines. And the gaming engine that we're using, as Ben says, is Unreal Engine 4 by Epic Games. And with that being said, I'm going to jump into the demo. Bear with me, I haven't presented.
It's got to be said, right? I don't know if you guys present, but presenting with headgear on, right, and he can't see you, is a completely new experience. If he had a time, he'd have put a clock in this and a video of you guys in it, but at the moment he's going blind, so bear with him if he looks like he's disorientated.
Okay, right then. Can everyone see this okay? So you've already been introduced to Cloud Consumer Electronics, which is our fictitious company whose microservices and APIs we deploy into the cloud onto the iPaaS for demo purposes. So we've got Cloud Consumer Electronics along here, powered by Capgemini Enterprise iPaaS. A bit of sales for you there. So there are three aspects to this model that I want to take you through. The first one is clearly the view of the Earth in the background there. There's the 3D model, which is center stage, and then there's also this list. And I'm going to start by explaining the 3D model. Now, if I take you over here, we have basically a river running along here, which represents the boundary between us and the internet. And we have two APIs which are public and accessible via the internet. And these are represented by this bridge, and this bridge over here. So we have the Tweet Feedback API, and we have the Social Media Service API. We also, on the bridge, if you can see, we have basically a barrier which tells us that this API is protected and that security is required before you can get through it. We also have a small building here which tells us about how many subscribers we have to that API. If you follow the road through, this is the first microservice which is responsible for servicing that API. That's why the road leads from there to there, and you can go nowhere else. And the microservices are represented as 4 houses. We have 4 instances of this microservice running, and they're shown as 4 houses. And they're also bounded by this fence here. Now, across the rest of the model, that's pretty much what you're seeing. You're seeing groups of microservices represented as houses with a clear boundary around them. So we look at this one, we've got the Yammer proxy service, which Ben mentioned, and also the Twitter proxy service. If we look across here, we've also got two external services. Now, we call Yammer and we call Twitter. And they're represented as toll booths, because every time we call Yammer, we get charged 2 pence. But every time we use Twitter, it's free. Now, that isn't true, I know, but for this purposes demo, it is true. We get charged 2 pence for using Yammer. The reason why these houses are blue and this ones are red is because they're a part of a different domain. The blue ones are part of the insights domain, and the red ones are part of the feedback domain. So that's the model. I want to talk about this list. This list is a list of journeys. So every time a user on the internet somewhere makes a call into our public API, that call or that request is then authorized. It then sets off a chain reaction across our system as it calls microservices and APIs and then external services. iPaaS collects all of that data about those requests to that propagation and basically makes that a journey and adds it to this list. So we can see that we've got 4 green, and a red one, so one of them clearly failed. Now, this list is okay, there's nothing wrong with lists. From here, I can see an individual service. I can see a social media API was called. Basically, that is what's being called across a lot of them. But I can see exactly what URL was there, how long each one took, and whether it was success or a failure. But the problem with a list like this, particularly when it's an enormous list, is you can't get a sense of aggregation. You can't look at that and say, well, which microservice has actually been hit the hardest? And also, like, am I getting, are they failing? Am I getting more successes than failures? And if they fail, where are they failing? We need something to aggregate that data and tell us what's going on. And that's what this model is all about. What happens is, as iPaaS adds journeys to this list, they pop off this list and they get applied to this model. And this model dynamically changes to reflect the aggregation. And that's what I'm going to show you. So first thing I'm going to do is I'm just going to start my simulation and immediately pause it. So those 5 journeys that we have here have now basically come from the internet onto our bridge, and they're represented as 5 cars. This is the initial request. Now, those requests clearly come from somewhere on the internet, and the best way of showing aggregation is via a world map or a heat map. Every time a request gets played out on the model, this map gets hotter. But I'm in a virtual world. I can touch this map and instantly change the view to something completely different. Now I have a different color scheme, plus the model's been annotated. And so I can get additional information. This map can represent anything we've got based on the information that we have. So let's put that back because I prefer the heat map. Continue with the simulation. Pause. So now you can see what's happened. Those requests have come across the bridge, and that bridge now is looking much more elaborate. It's certainly more elaborate than the one over there. So it's clearly easy to distinguish which one is getting the most traffic, because this bridge clearly has more money spent on it to cater for the traffic that's coming through. We also have this, this house now, which has got much bigger, to say that we're getting much more subscriptions to this API than we want over there. The microservices have done exactly the same thing. These flats, these houses turned into a block of flats, so clearly that microservice gets more traffic than the other ones. Just going to continue the journey. So what's happening now is more requests are being fired out across the infrastructure as these microservices communicate with each other. But aggregation is important, but what happens if I want to interrogate an individual request and see where it plays out in the model? Well, let's just touch this error. And what we see now is that that request has now been mapped out in green, whereabouts which microservices it touches, but it's also telling us in red whereabouts it failed. So I can do this with any of them. I can touch any of these, and I can switch between each request. I'll turn this off. Now, in the interest of aggregation, in terms of errors, if we look at this road here, you can see there's now some wear and tear on it. There are some tire marks. So basically, every time an error occurs on a road, and the more times errors occur on the road, the more it degrades, the more it looks like it's got wear and tear. So when you instantly glance at the model, you can see the difference between those roads that are in trouble and those that aren't. They're finally going to drive through to our external service. And if you noticed, this is the total cost that we've been charged when we call Yammer. It started off as £10. We get charged 2 pence, and now it's gotten £10 and 8 pence. So again, the model's reflecting the aggregation.
5 minutes.
And that's essentially, the model now plays out. The requests finish off calling the different microservices, and then the simulation finishes. Wow, that's hot in there. Let me just maintain some dignity. Okay, so that's our model. That's our way of trying to represent IT in a completely different way. If this was your business and that was your IT, that town would be a landscape that you'd become quite familiar with and quite comfortable with. And you could watch it grow and you could even nurture it. And if you might be thinking, well, what happens if I don't have a few microservices? What happens if I've got hundreds of these things? You're no longer managing a town, you're managing a city or a metropolis. It just gets bigger, and the tool should cater and help you use that model. The thing I like about this, personally, is that I think we're beginning of a journey where we can start bridging the gap between non-technical and technical people. We can start creating models that both of us understand without some detailed conversation or extensive education. We can basically create a model that we just understand. And to try and put this in context, some of the software that I use on a daily basis, my grandmother would be baffled by most of it, if not all of it. But I could guarantee that I could have a really good chinwag with her about towns, journeys, and world maps. Thank you very much.